Hey guys, welcome back to my channel. Thank you very much for joining me for this live. I'm going to explain the 68, the 95, and the 99.7% rule for one of my students. So here we go. Okay, the name is right here. All right, Miss. Here we go. So the question says a group. Here we go. So the question says a group. Why am I hearing myself? Okay, here we go. This is a group of Dutchmen are among the tallest people in the world. The average Dutchman has a height of 184 centimeters and has a standard deviation about 8. So you have to assume that the distribution is normal, and you're told to use the 68, 95, and the 99.7% rule to sketch a model of the height for the Dutchman. Label the axis clearly indicating the appropriate percentages. All right, so right here, before you move on, you know that when it says it's approximately normal, you think about your bell curve, you think about your data being symmetrical, all right? And so once it's symmetrical, we're gonna draw our bell curve. The center represents the mean. We move 1, 2, 3 standard deviation to the right, and the same standard deviation to the left. So we're asked to examine the 68, the 95, and the 99.7 rule, and these tell you the standard deviation of each point from the mean. So 68% is within one standard deviation of the mean. I'm gonna change the color. So 68 is within one standard deviation. 95 is within 2 standard deviations of the mean. And the 99.7 is within 3 standard deviations of the mean. Alright, so once you know this rule and you know how to represent them on your bell curve, you go ahead and add your mean and your standard deviation. So we know the mean goes to the center. So I'm going to go to the other side. So, or maybe I could just put it right here. What do you think? Put it right here in this graph? Put it in this graph? No? Alright. So let's change the graph. So that is the actual measures they gave us. So they gave us the mean to be 184, so it's 184 in the middle, and the standard deviation is 8. So if you're moving to your right, or the positive standard deviation, we're going to be adding our 8 as we go along. And mine is not drawn to scale, so just bear with me with that. So 184 plus 8 will give you 192. 192 plus 8 is going to give you 200. 200 plus 8 is going to give you 208. If you're moving to your left, we're going to be subtracting the standard deviation. So that's -1, -2, -3. So right here, 184 minus 8 is going to give you 176, I think. 176 minus 8. Or maybe I should change the color as well, since we're going to go in the opposite direction. So we're going to minus 8 here. So that's 176. 176 minus 8 is going to give you 168. 168 minus 8 is going to give you 160. So I'm going to put a box around all the critical points that we're paying attention to. So this represents 3 standard deviations from the mean for the men's height, for the Dutchman's height. Alright, and we just label the axis based on the percentages given. Part 2 says we need to recall the scenario above, which is this one, and we're asked to tell what percent of all Dutchmen should be over 200 centimeters. So over 200 centimeter is your point right here, which says 2 standard deviation. So 200 is in line with the 168. So that's the 95% rule acting out right here. Are you following? Alright. So that's positive 1, that's positive 2, that's positive 3. Right? And so because 200 is in the 2 standard deviation, you pay attention to the 95% rule. Follow? So it says Dutchmen over 200, meaning everything above 200. So if we know that the area under the curve is equal to 100%, and if 2 represents 95%, that means we have 5% remaining, right? And because it's symmetrical, we know that that 5% must be split into 2 parts. So some represent this area and some represent this area. So we'll say 100 minus 95 to give us 5. We need to divide this by 2 to give us 2.5. That means, let's change the color. That means 2.5 is on this side, 2.5 is on this side. So remember, the bell curve is a never-ending line. It continues on and on. So the further it goes from 3, the smaller the percentages are. So 2.5 here, 95 here, 2.5 here, gives you the total of 100%. So the question after the percentage of Dutchmen over 200 centimeters, so the answer is 2.5. Some people will give you 2.35, which is a bit simple approximation. Your answer wouldn't be incorrect, but to get the precise answer, you just subtract from 100, divide the number by 2 to give you the equal amount on either side. Any question? Any question? You can talk. They can hear your voice. They can see your face. You can talk.
Can you pause it?
No, because talk. It's okay. You can talk. They can't see your
No, I
face.
think I'm getting signed out
What time?
right now.
No, you're gonna have to wait first.
Okay.
Alright. So the next part says, let's say you take 20 minutes on average to drive to school with a standard deviation of 2. You're asked to draw a similar curve representing the 3 standard deviation above the mean and below the mean. So again, you draw your bell curve. The mean goes in the middle. To your right, you add. So it's 1, 2, 3. So it's plus 2. So it's 22, 24, 26. This direction, you subtract 2. So it's 18, 16, 14. You have that? Yeah? Now it says we must examine the 68-95% rule to answer the following questions. So it says about how often will it take you between 18 and 22 minutes to get to school. So we know that's 68, which means that's 34, and that's 34. That's 95. If you divide this by 2, we should get 47.5. That means here is 13.5. Here is 13.5. This part here is 99.7%, which means it's going to be 49 point something. So here is 2.35, and here is 2.35. Outside of it, it'll give you 0.15. Outside here, 0.15. And this is a given for all questions related to the normal model. So if you can remember these percentages for any test coming up, that would be very useful for you. So it says so what percent is between 18 and 22? So 18 and 22 is in the middle here. You all see that? Let's put a box around the critical points so you can see what we're talking about. So it's 18 and 22. So what would be the percentage here? 68%. So 34 plus 34, so that's our 68%. The next part says, how often will you arrive to school less than 22 minutes? So less than 22 minutes. Right here, 22 is at 1 standard deviation, right? Positive 1. So less than 22 will be everything going down that way. But we know right here represents 68. So that means up here will be 16. Down here will be 16. How did I get that? So I say 100 minus 68 will give me 32, which means split it in two, half here, half there. You divide this by 2, you'll get 16 above and 16 below. Or you could say 13.5 plus 2.35 plus 0.15 should give you the same 16%. So 16% above, 16% below, and 68 in the middle. So less than 22, we say it's going to be 68 plus 16 to give us 84%. So the next question asks us, how often will it take you more than 24 minutes? So it says more than 24 minutes. Twenty-four is represented by 2 standard deviations, so we basically, so that's positive 2, that's 1, that's 0, negative 1, negative 2, negative 3, positive 3. So more than 24 is all of this region right here. If you want to, you could say 2.35 plus 0.15, or you could say, since that is outside of 95%, which is these two, do the same thing. 100 minus 95 to give us 5 divided by 2 is 2.5. So it's 2.35 plus 0.15. Am I going too fast? Okay. So the answer is 2.5% of the time. It takes you more than 24 minutes. And the last part says catch the bell curve, and I did that before, so you should receive maximum points here. Alright, last question. That's the one to the back. I'm gonna write the formula on the board and then give you. Should I go back? I see you looking up. Should I go back to the first slide? Okay. Z-score. So the question to the back says the average reading speed of students completing a speed reading course is 450 words per minute. If the standard deviation is 70 words per minute, find the z-scores associated with each of the reading scores given below, and you're asked to show working. So z-score is basically standardizing all your data values where everybody will be on the same path. That's the reason why you see when you have your bell curve, you see 1, 2, 3 instead of actual numbers. So right here, all the values have been standardized. So the z-score here represents actual averages just in a standardized way. Alright, so let's say that the average speed is 450. Average here, basically the mean is 450. A standard deviation of 70. Standard deviation of 70. And you're asked to find the z-score when your first score, let's say A is 320. You need to find the second one is 474. The third one, when it's going to be 610. So looking at these numbers, you should be able to tell if it is a negative z-score at the end or a positive z-score based on the values you have. So if the number is less than the mean, your z-score is going to be negative somewhere in this region. If your number is greater than the mean, like these two, your z-score will be in the positive direction. And remember, the higher the z-score is, the better the person's performance or standing. So the z formula is x minus x bar all over standard deviation. X here is your data value. X bar represents your mean. And you know SD is your standard deviation. So let's plug in what we're given. So we're given all the x values. and the mean and the standard deviation stays for all of them. I don't have a calculator beside me, so I needed to tell me some answers because I can't do it in my head. Alright. So xz is equal to x is 320 minus x bar, which is 450, divided by 70. So you basically plug the values in to give an answer.
-1.85.
Okay, so we have z negative 1.85. So negative 1.85 is somewhere down here. See that? So it's a negative z score. So our answer proves true. Alright, let's go for this one. So it's going to be the data value, 474, minus the mean divided by standard deviation. So it's 474 minus 450 divided by,
I got like 0.34.
yeah, points, yeah, so it'll be a small number. So it's 0.34. And it is that small because the mean is 450, and so 474, look, will be very close to it. 474 will be somewhere close here because of the standard deviation. So 474 is somewhere right there. So that's the reason why your z value is so small. And it's a positive number, so it's positive 0.34. The next part is asking us to find for 610, so it's 610 minus the mean, 450, divided by standard deviation, which is 70. And this should be a pretty big number, above 2, right?
2.28.
Yeah, 2.28. So the z score is 2.28, which is somewhere down here. So it's pretty unusual. So one thing to remember is that when your z values fall outside of 2 standard deviation, they're considered to be unusual or abnormal, but they're still considered very high performance. Anything else? It says identify the z score that fell below the mean, and you know the negative z score is the one that falls below the mean. And another one says identify the word per minute with the highest z score. You basically look for the number that's largest out of the 3 that's given. Alright, so this question is pretty simple. It says the regional mean for verbal score on an exam was 428 and had a standard deviation of 113. So my mean is 428 and my standard deviation is 113. And I'm asked to tell the approximate percentage for persons who are taking a verbal test who had a score between 315, so it's 315 and 541. So here, what you basically do is you have 2 options. You can work this calculation way, or you can draw your bell curve and identify the region. In my opinion, drawing a bell curve and seeing the region will be pretty simple because these numbers are either 1, 2, 3 standard deviation from the mean. So I need someone to subtract these numbers for me and tell me get for your answer. To my left, so it's 315, 202,
And 89.
189.
Just 89.
Oh, it's that big. 89. This way,
541.
541,
654.
654,
And 767.
767. Alright, so we're asked to tell the percentage for the data that falls between 315 and 541. As I was saying to you, you guys know the 68, the 95, and the 99.7% rule. So all you have to do is to identify the numbers they gave you, which is right here, and right here, and tell the percentage that falls between one standard deviation, which here is 34, here is 34. So the total thing is 68%. Or you could have done the other way, where you know the mean is 428, you know the standard deviation is 113, and you know the first value is 315, that's x1, and the second value is 541. Use your z formula, so it's x minus x bar or that, to find it for each of them. But since we can draw the graph and it's pretty simple, we choose the graph method. Alright, let's go to the other question. It's going to be your final one. So it says, it is given that the battery life is normally distributed for large samples. The mean life is 500. So the mean, x bar, is 500. And the standard deviation is equal to 61. And you're asked to tell the approximate percent of life that lasts longer than 561 days. So x is 561, and we want longer than 561, same as saying more than 561. So again, you have two methods of doing this. You can either use the calculation or you just draw your bell curve. But since as I see that 561 is like one standard deviation above the mean, I'm going to draw my curve. And I only want to pay attention to the first standard deviations. So that's 561. What is 500 minus 61? 4 something, 39?
Wait, what?
500 minus 61? 439?
9.
439. Alright. So we just talked about this on the previous slide, where we say that if here represents 68%, to know what's above 1 and below 1, we say 100 minus 68 to give us 32. Divide that by 2 because it's symmetrical. That means up here is 16% and down here is also 16%. But since I want the days longer than 561, I need everything above this region, which will eventually be 16%. You see how I got that?
Mm-hmm.
Any question? No?
No.
Okay. Frost? Okay. Yeah, that's practically what the assignment was, and for you to complete it. So saying to you, if you can manage to do these questions, you can
That's
do the quiz that's coming up.
That's
And I told you that I want to compromise myself by giving you too much information. See what I'm saying? All right. All right, guys, that's the end of our video. Remember to like, share, comment, and subscribe. Tell a friend to tell a friend to come over and learn something here. All right, we're gonna be going on because our class will be starting in a minute. So, see you guys.